In science and technology, especially in the field of artificial intelligence, there is a question that is rarely asked in public, yet silently determines the future of entire systems. Who decides when risk is acceptable? Who defines the boundary between innovation and danger? Who decides when an error is tolerable and when it becomes a collapse? This is not an abstract philosophical question. It sits at the very core of how real AI systems operate, from algorithms that run financial markets to models that influence decisions in critical infrastructure, public safety, defense, healthcare, and information. And the uncomfortable truth is this: these decisions are not made by conscious algorithms, nor by social consensus, nor by democratic vote. They are made within technical, institutional, and economic structures that remain largely invisible, embedded directly into the architecture of the technology itself. This video is not speculation, personal opinion, or exaggerated futurism. What you are about to see is an analysis grounded in science, technology, and real-world risk control systems in artificial intelligence. And the question that remains is direct. If AI causes a collapse, who decided that the risk was worth taking? Before continuing, think about this. Do you trust AI systems operating without your knowledge of which risks were accepted on your behalf? And what if those risks are already active right now? In science and technology, the concept of acceptable risk does not mean the absence of danger. It means operational tolerance. A risk is considered acceptable when the expected cost of mitigating it is greater than the expected cost of living with it. This logic is applied every day in engineering, economics, data science, and increasingly in artificial intelligence. In AI systems, risk is not eliminated. It is managed, calibrated, and pushed forward within margins deemed economically, technically, and strategically viable. These margins do not emerge from universal principles or abstract ethics. They emerge from human decisions, translated into metrics, thresholds, stress tests, and technical protocols. In other words, before asking whether artificial intelligence is safe, it is necessary to understand how risk is defined within these systems. In scientific research environments in artificial intelligence, such as major science and technology laboratories linked to corporations, universities, and states, decisions about risk begin long before any system enters production. Researchers must define, even during development, which behaviors are acceptable failures during testing and which require immediate shutdown. And here is a key point. These decisions are technical, but also strategic. Stopping a system too early can delay competitive advances, jeopardize funding, or leave room for competitors. Advancing with known risks may generate future externalities, but maintaining momentum guarantees advantage in the present. Even in science, risk is never neutral. It is always weighed against institutional objectives, performance metrics, publications, patents, and technological power. Now, pause for a moment. Do you think these trade-offs are made with you, the end user, in mind, or with the system as a strategic asset? When artificial intelligence systems leave the laboratory and enter large-scale production, the definition of acceptable risk shifts to another level. It becomes directly shaped by economic incentives. Companies operating AI at global scale face constant pressure for efficiency, growth, profit, and market dominance. In this context, technical risks that do not cause immediate failure tend to be tolerated. The cost of shutting down, delaying, or redesigning a system is often higher than the potential cost of a future failure, especially if that failure can later be treated as an exception, a bug, or an unexpected side effect. As a result, decisions about risk in AI are internalized as business decisions, even when they affect critical systems in science and technology. If you've made it this far and this kind of analysis resonates with you, like the video and subscribe now. That signals to the algorithm that content about AI, technology, and systemic risk needs to reach more people, and you won't want to miss the next videos in this series. But companies do not decide alone. There is another level of decision-making that is even more invisible. Governments enter this process primarily through regulation, but rarely with direct technical control. In practice, regulations define general limits, abstract principles, and formal obligations, while concrete implementation remains in the hands of companies, engineers, and specialists. And moreover, states themselves depend on artificial intelligence for defense, surveillance, logistics, strategic intelligence, and information warfare. This creates profound conflicts of interest. Regulating too much means losing technological capacity to other countries. Regulating too little transfers risks directly to society. The result is an unstable equilibrium, where decisions about acceptable risk in AI are fragmented, distributed, and diluted among multiple actors, with no one holding full control, but everyone holding some degree of power. And who is left out of this process? Users and populations affected by artificial intelligence systems almost never participate in decisions about risk. They interact with systems that are already deployed without access to the technical, economic, or political premises that justified their adoption. Risk is imposed, not negotiated. Even human operators who supervise AI systems, analysts, technicians, moderators, generally lack the authority to redefine risk limits. They execute protocols defined by higher layers, often without full visibility into how the system actually works. So-called human control exists formally, but is limited in practice. And this fundamentally changes the idea of control over artificial intelligence. When AI risks materialize, the impacts rarely fall on those who made the original decisions. Systemic failures, algorithmic bias, operational collapses, and informational distortions generate social externalities that were not fully priced at the time the decision was made. Accountability tends to occur after the damage, not before. Fines, investigations, and corrective adjustments emerge once the impact has already spread. This creates a dangerous cycle. Risky decisions continue to be made as long as their costs are not immediately attributed to the decision-makers. Here is an uncomfortable but necessary statement. There is no purely technical solution to defining acceptable risk in artificial intelligence. Metrics, tests, benchmarks, and validations reduce uncertainty, but they do not eliminate value judgments. Engineering can inform decisions, but it cannot replace them. Even when framed in technical language, decisions about risk in AI are political in a structural sense. They distribute costs, benefits, and responsibilities among different groups. This is precisely where science, technology, and power intersect. As artificial intelligence systems become infrastructure, decisions about risk shift from the technical level to the institutional level. The question is no longer whether the system is safe or not. The question becomes whether the risk is acceptable given the available alternatives. After the point at which AI systems can no longer be easily shut down, the central question changes. It stops being, how do we make AI perfectly safe, and becomes, who controls the decisions about risk? In science and technology, this means recognizing that control over artificial intelligence does not lie only in code, but in the structures that decide when failures are tolerated and when they are not. The future of AI will not be defined solely by technical advances. It will be defined by how societies choose to deal with risks that can no longer be eliminated, only distributed. "It begins" does not mark the start of a machine rebellion. It marks the beginning of an era in which decisions about artificial intelligence cease to be merely technical and become structural, continuous, and profoundly human. In the next step, the analysis goes even deeper into a more sensitive question. Can these decisions ever truly become transparent, or is opacity part of the system itself?